Hello students, today we shall see the next point of our chapter memory management, that is disk scheduling algorithms. In the previous lecture we have seen what is disk scheduling. To do disk scheduling we are going to follow, or the operating system will follow, one of the disk scheduling algorithms. Today we shall discuss the different disk scheduling algorithms. The first one is first come first serve algorithm, or FCFS algorithm. In this algorithm, the request at the front of the queue is always selected to be serviced next. That is, the requests are served on first come first serve basis. The request which has come first, or which is first in the waiting queue, will be taken for operation. The requests are served on first come first serve basis. It is the simplest scheduling algorithm. The requests are scheduled in the order they arrive in the disk queue. Thus, every request gets a fair chance to be executed, and indefinite postponement of request does not occur. As the requests come in the waiting queue, they are serviced. It may be possible that the first request in the queue is very far from the current position of the disk head. In this case, the seek time will be high and throughput will be low. Seek time and throughput are the two important criteria in disk scheduling algorithms. So, if the head position is far away from the next request, then the seek time will be high and therefore the throughput will be low. This algorithm is fair, but it generally does not provide the fastest service, because maximum time may be wasted in moving from one block to another block. We shall see this first come first serve algorithm with an example. Consider, for example, a disk queue with request for input or output to blocks on cylinders. This is the given block number of cylinders. So with the help of this diagram we can understand how the read-write arm or head will be moving. If the disk head is initially at block number 53, okay, so our disk head is at the first position at 53. If we are following the first come first serve scheduling algorithm, in this given queue the first one which had come was block number 98. So from 53 the disk will move to block number 98. So in this case the head has to move from 53 to 98, that is 45 tracks. It has to travel 45 tracks from here and go to 98. From 98 the next in the queue is 183. So from 98 it has to go to 183. So to go from 98 to 183, it has to travel to 85 tracks. So here plus this. Now from 83, which is the next one in the queue, it is 37. So from 183 the head will move to 37. Next in the queue 122. From 37 to 122, from 122 to 14, from 14 to 124, from 124 to 65, and then 67. So now in this case it has to travel total 640 tracks. That is the difference between 98 to 53 plus the difference between 183 to 98 plus the difference between 183 to 37 and so on. Total it requires 640 tracks. So here you can see that the head has to move so fast and very far track positions. So this is all about first come first serve disk scheduling algorithm. I hope you have understood this algorithm. Next we'll move on to shortest seek time first algorithm. This algorithm suggests to the operating system to select the request for the cylinder which is closest to the current head position. As we have seen in the previous algorithm, the head has to move from back forth. Instead of that, what we are going to do is we are going to select a track which is nearby to the given head position. In this algorithm, the request with the shortest seek time will be executed first. Therefore, it calculates the seek time of all the requests in the queue, selects the appropriate request and schedules it for the execution. So in this case, the operating system will calculate the seek time for all the requests in the waiting queue, and that block number which has the least or the less seek time will be scheduled or will be serviced. In this way, the requests that are near to the current head position get serviced first, thereby improving the performance of the system. This will increase the throughput of the system and decrease the average response time as compared to first come first serve. In first come first serve, the seek time was high and therefore the throughput was low. Now in this case, it will increase the throughput and decrease the average response time. Since it needs to calculate the seek time from the current disk head position, it will occur a cost of computation. Every time the operating system has to calculate the seek time for each and every block in the waiting queue. This has to be given some extra time, so the cost of computation will increase. Another drawback in this algorithm is that a request very far away from the current head position will not get scheduled if the arriving request have less seek time compared to this request. In this case, the request will starve. Since the algorithm services the request whose seek time is less, the requests that are concentrated in one region will be served the most. This may cause in low response time for the request is at the other end of the disk. This algorithm can cause some request to wait indefinitely, and this problem is called starvation. So shortest seek time first has one problem, and that is known as starvation. All the requests which are present at the current head position will get serviced, and those requests or blocks which are at the other ends will remain as it is. So this is known as the problem of starvation. So we are going to see an example. So the current head position is at 53. Now the closest request to the initial head position 53 is at cylinder 65. So compared to 14, now this is the waiting queue. From this waiting queue, which one is closest to 53? It is 65. So this request will be serviced. So the head will move from 53 to 65. Now from 65, which is the closest request? it is 67. So from 65 now the head will go to 67. So this block will be serviced. Now from 67, which is the closest one? So it will go over here to 37. So from 67 it will go to 37. Now to 37, which one is the closest? So it will go to 14. It will service. From 14 it will go to 98. From there 122, 124 and 83. So now in this case the head will travel minimum of 236 cylinders. In the previous case, that is in first come first serve algorithm, the head used to travel 640 cylinders. In this case it is going to travel 236 cylinders, which is better than first come first serve. So this is the second algorithm, disk scheduling algorithm. Now we are going to see the third disk scheduling algorithm, that is the SCAN algorithm. In this algorithm, the head starts at one end of the disk and moves towards the other end, servicing the request at cylinders that are on the way. Upon reaching the other end, the head reverses its movement and continues servicing the requests that are on the way. This algorithm is simple and almost totally avoids the starvation problem. This algorithm uses the property that the disk arm, after reaching the end of the disk, moving in one direction, that is the outermost or the innermost cylinder, reverses its direction. It services the request in the direction of its head movement and continues until it reaches the end of the disk or the last cylinder. After this, it reverses the direction and services the request in its path. According to this algorithm, the preferred direction of the head movement has to be found first, and all the requests in that direction will be serviced. It may be possible that some requests appear while processing a request. If these new requests are in the path of the preferred direction of the movable disk head, then this request will also be serviced. However, if they arrive just behind the head, then they will have to wait until the head reverses its direction and services them. Whereas a new request that is in the front of the head will be serviced almost immediately. In this way, the head moves back and forth across the disk and services the request in its path. Hence, the algorithm is also known as elevator algorithm, taking the request in its path. Elevator means the lift which we use in the building for going up and down. This lift also follows the same. Hence, the algorithm is also known as elevator algorithm, taking the analogy of an elevator that continues in one direction, servicing each floor as per the request, and reverses its direction after reaching the top or ground floor. Now with this example, we shall see the working of SCAN algorithm. The head position is at 53 if the disk arm is moving towards 0. If the operating system selects this direction, the head will service 37. So from 53 it will go to 37 and then 14. At cylinder 0, from 14 it will go to 0 even though we don't have a request at 0. At 0 the arm will reverse and will move towards the other end of the disk servicing the request at 65, 67, 98, 122, 124 and 183. So in this case totally it will cross 623 cylinders. So this is the working of SCAN algorithm. The operating system will select one direction. While going in that direction, it will service all the requests. It will go to the last track, that is 0. After reaching the last track, it will reverse its direction, and while coming back it will service all the requests, and then it will go to the last track, that is 199. After reaching 199, it will again reverse the direction and request all the services in the other reverse direction. So this is the SCAN algorithm, which is also known as elevator algorithm. Next we shall see the CLOOK algorithm. A little modification of SCAN algorithm is CLOOK algorithm. Under this, the head starts at one end and scans towards the other end, with servicing the request on the way, just like the SCAN algorithm. However, here the head does not necessarily reach the end of the disk. Instead, where there are no more requests in the direction in which the head is moving, it reverses its direction. So this CLOOK algorithm is similar to the SCAN algorithm. In SCAN and its variants, the disk head moves to the last cylinder and then reverses its direction. In this case, the head moves unnecessarily, thereby increasing the delay. Therefore, another modification is made in these algorithms such that the head moves in one direction only till the last request in that direction. So in this CLOOK algorithm, it does not go up to the last track, that is 0 or 199. CLOOK algorithm solves this deficiency. According to this, the disk head looks ahead in its direction of movement for the last request. It moves to the last request and changes its preferred direction, therefore without moving to the last cylinder, and continues servicing the request in the other direction. So in this case you can see the operating system has selected this direction. At the starting position 53, it will service 65, 67, 98, 122, 124, 183. In SCAN, this head will go up to 199 and then reverse the direction. But in CLOOK algorithm, it will only go up to the last request and then change the direction. That is, it will look if there are more requests in the given direction or not. If there are no more requests in the given direction, it will stop there and reverse the direction. While coming back, it will service the remaining request, that is 37 and 14. So this is a variant of the SCAN algorithm, that is the CLOOK algorithm. Next we shall see CSCAN and CLOOK algorithms. These are the variants of SCAN and CLOOK algorithms. CSCAN stands for circular scan and CLOOK stands for circular look, are the variants of SCAN and CLOOK algorithms respectively, which are designed to provide a more uniform wait time. In these algorithms, though a head scans through the disk in both the direction, it services the request in one direction only. That is, when the head reaches the other end, it immediately returns to the starting end without servicing any requests. So here you can see that SCAN algorithm, it will select one direction, it will service all the requests in the given direction, go up to the last one, and then reverse its direction, directly come to the first track. While coming back, it will not service any request. and then again it will start the direction and service the request. So all these requests will have a uniform waiting time. In SCAN algorithm, after changing the direction, it also service the request while changing the direction. In CSCAN, it does not service the request while changing the direction. Similarly, CLOOK. In CSCAN, it will come up to the last track, but in CLOOK, it will not come up to the last track. It will select one direction, service all the requests, and come only up to the last request. From there it will change the direction, directly come to the first track. It will not come to 0. In SCAN it comes to 0. You can see over here it goes to the extreme points. But in case of CLOOK, it does not go to the extreme points. It will change the direction, come to this, again start servicing the request. So CSCAN and CLOOK are the two variants of SCAN and LOOK algorithms. With this we finish with all disk scheduling algorithms. Thank you.